Welcome, students. Today we dive into the profound principles of Newton's laws and momentum. These concepts are at the heart of classical mechanics and provide us with a profound understanding of how objects move and interact in the physical world. Let's embark on this enlightening journey together. Newton's laws of motion are fundamental principles that describe the relationship between the motion of an object and the forces acting upon it. These laws, formulated by the brilliant physicist Sir Isaac Newton, revolutionized our understanding of motion and laid the foundation for classical physics. The first law, often referred to as the law of inertia, states that an object at rest will remain at rest, and an object in motion will continue moving in a straight line at a constant velocity unless acted upon by an external force. In simpler terms, objects tend to resist changes in their motion. If you slide a book on a table, it eventually comes to a stop due to the frictional force acting against its motion. The second law of motion relates the acceleration of an object to the net force applied to it and its mass. It states that the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. Mathematically, this law can be expressed as F equals sine ma, where F represents the net force, m represents the mass of the object, and a represents the acceleration it experiences. This law highlights the concept of force, which is a measure of the interaction between objects. Force can cause objects to accelerate, decelerate, or change direction. It can also cause objects to deform or exert pressure on other objects. Understanding forces is essential for analyzing the motion and interactions of objects in various situations. Now, let's explore the third law of motion, often known as the law of action and reaction. This law states that for every action, there is an equal and opposite reaction. In other words, when one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. For example, if you push against a wall, the wall pushes back with an equal amount of force. It is this interaction of forces that allows us to walk, swim, or even propel rockets into space. Moving on to momentum, it is a fundamental concept in physics that describes the quantity of motion an object possesses. Momentum is defined as the product of an object's mass and its velocity. Mathematically, momentum, p, can be expressed as p equals sine mv, where m represents the mass of the object and v represents its velocity. One of the most intriguing aspects of momentum is its conservation. According to the law of conservation of momentum, the total momentum of a system remains constant if no external forces act on it. This means that in a closed system, the total momentum before an event or interaction is equal to the total momentum after the event or interaction. This principle has significant applications, such as understanding the recoil of firearms, collisions between objects, and the behavior of particles at the atomic level. By understanding Newton's laws of motion and the concept of momentum, we gain a powerful toolkit for analyzing and predicting the behavior of objects in motion. These principles allow us to understand the forces acting upon objects, the relationship between force, mass, and acceleration, and the conservation of momentum in various scenarios.